Okay, so again, thank you everyone. Welcome to our fourth day. And we're going to kick off with the IRG AVQA segment, and the podium goes to Chulhi to walk us through the rest.
Okay, do you see my screen?
Yes, we can, Chulhi.
Okay, thank you very much. Good morning. So just let me briefly introduce IRG AVQAs. This interaperture group was initiated by Arthur Webster. He was the chair of study group 9, and we have study group ITU-T side and ITU-R side. So sometimes we are doing quality-related recommendation without knowing what other side are doing. So through this IRG AVQAs, we are going to some coordinations and can identify potential work items, which can be progressed as a joint text recommendation. Also, we can some benefit from the co-location with the meeting of VQEG, where video and audio quality experts meet and execute their technical works. So this one main goal is to encourage a collaboration between the ITU-T study group 12 and ITU-R study group 6 on work items. And some goal, so through these interaperture groups, we exchange the information, and also we seek participation from the broad range of ITU members, which also include VQEG members and some non-member expert, for example, from academias. So we can share information, and also most importantly, any VQEG members who has some good work item which can be developed into recommendation, they can get some help or some, so that their method could be developed into ITU recommendations. So I think through this collaboration, I think we can share and help so that the better recommendation can be developed. So I'm representing ITU-R work study group 6, and Alex represent ITU-T study group 12. First, let me introduce some recent work item, ITU-R working party 6C. So some interesting work item related to quality. So is the ultra high definition televisions. So we have this WD means working document, preliminary draft new recommendation, HDR, ultra high definition television reference test patterns. So this one is in the early stage because it's all the working document. Usually if we have this working document, at the next meeting, you may submit the PDNR, preliminary draft new recommendation, and the following meetings, you can submit the draft new recommendation, and during that meeting, it can be consented, and then it went through the member state votings. And the next one is the PDNR report, experience of ultra high definition and high dynamic range televisions. So as you can see here, now the broadcasting study group, which is a study group 6, they are now working on the HDR and UHDs. Also, we have high dynamic range television recommendation being developed. So we have a working document, PDNRs, so requirement and application for image level meters. So if we have a good metrics, I think you can contribute to this effort. And also we have a quality evaluation methods, working document, PDNR, ITR, BT, MF3s, a measurement framework for broadcasters to assess their Scope 3 impact of television displaying television programs. So this is a selected work items. If you are interested, you can go to ITR website, then you can find some text under the work item under development. So as you can see here, there are many categories: ultra-high definition televisions, advanced immersive sensory media, advanced sound stream, sound system, ESG, HDR TV, loudness, production of ultra-high definition televisions, and quality evaluation method and sensory media systems. So this is some of the topics developed in the ITR. So if we have some topics related to this kind of areas, then you can submit some contributions, which so that it can be developed into recommendation. So we have meeting last March. So we have last March was not very active. So we have some contributions related to qualities. So we have about the algorithm to measure audio programs, loudness and true peak audio levels, and performance analysis of a no reference video quality assessment method, and also progress report on high dynamic range televisions, and also algorithms to measure audio program loudness and true peak audio levels. So this is the recent contribution related to quality. Also keep in mind that there are other broadcasting related contributions, including broadcasting method, and also some terrestrial broadcastings.
Chulhi, sorry if I interrupt, this is Yanni. On the second bullet, you also being on the ITUT study group 12, what's the relation between these no reference methods and the one studied under JNOREF?
No, it's about the same, because I think you have a long stories. It's in the about 25 years ago, ITR and ITUT both doing objective measurement technologies to develop recommendations. So they are doing separate. So in some way, they are overlapping. So first recommendation on full reference method was first consented in ITR side, and also the similar recommendation was consented in ITUT at the time study group 12. So ITR study groups, study group 6 and ITUT study group 12 both have quality development. So in the older days, we have similar recommendation in the both group, but recently ITT is more active. But still, ITR, we can make the similar recommendation, because T side is targeted for telecommunication and ITR side is for the broadcasting. So this one is the same topics. So I think I'll talk with the management and also the study group chairs that once we successfully develop recommendation on ITUT side, if there is a need and request, we can also proceed to develop similar recommendation in ITR side.
Thank you.
Okay, so now let's move to study group 12. Study group 12 is just a study group related to qualities, QoS and QoEs. So entire questions on the study group 12 is related to quality somewhere. And study group 12 has met last January from 14th to 23rd. Let me see. Okay. So we have a study group 7, whose rapporteur is the Ludo. And the title of this question is Methodologies, Tools, and Test Plans for Subjective Assessment of Speech, Audio, and Audiovisual Quality Interactions. And in these questions, we have 4 work items. Work item means this one is proposed to be developed into recommendations. So they are working on these technologies so that if there is sufficient information and the text is scalable, then they will present this one for consent. So if that is the case, then it will become recommendations. So after that, they will have this number, for example, P.835, as I think everyone knows the H.264, that's IT recommendations. So this is the similar recommendation, P.835. And also we have a P.subgress, gender-related aspect of speech transmission, quality analysis. And the subjective test methodology for noise compression performance in internet real-time communication services. And out lab conducting subjective tests outside of the labs. So this is the recommendation received in last January. Also, we have a question 19. The rapporteur is the chair, conveners, is Jens Berger. Perceptual-based objective method and corresponding evaluation guidance for voice and audio quality measurement in telecommunication services. So they have 5 work items. P.SEMD, single-ended perceptual approach for multidimensional analysis. And also now they are revising P.863 for considering low bitrate codecs. So they received 3 contributions during the last January meetings. So as the new technology coming into the market, if there is some need, they just propose that they're developing new recommendations for the new technologies. And question 10 is the rapporteur is Gunilla Bonstassens and Janto Skoronex. So this the conferencing and tele meetings assessment. So they have 3 work items: interactive test method for subjective assessment of extended reality communications. And this one is some collaboration with the VQEG IMGs. Also, they have P.UXV, user experience for multimedia in video telephony and video conferencing services. And P.XRT, quality evaluation framework for extended reality terminals. So during last January meeting, they have some extensive contributions to progress these 3 work items. So this is the list of the contribution received in last January. And the next one is the question 13. Rapporteur is Katrisa. I saw Katrisa yesterday, but looks like he's not here. Is there?
Katsuhisa is not here today. He went back to Japan yesterday.
Okay, then I'll do the presentation. So this one is the quality of experience, quality of service, and performance requirement and assessment method for multimedia applications. And they have 2 work items, P.SEM SMART, subjective test for evaluating the user experience for mobile AR applications, and MF-VR, measurement of quality influencing factors for virtual reality services. So I think Patricia also had some collaboration with VQEG in the past, and in the January they received 3 contributions to progress these 2 work items. Also, as you can see here, there's some collaboration with VQEG 5G KPI. And next one is question 14, chaired by Rapachot, Yogen, and Alex. This question has been very active, producing a lot of recommendations related to quality measurement. So current work item is P.1204 extensions. So they extend the recommendation to support new codecs. And also question 1204.2, video quality match assessment of a streaming service of a reliable transport for resolution of the 4Ks. So this one is still some development. Then P.BBQCG, parametric bitstream based quality assessment of cloud gaming services. And P.NETS code extensions and panoramic non-intrusive bitstream assessment for high efficiency video codings, and 4K media streaming quality of UDPs. And P.NETS PH3 phase 3 quality integration module for adaptive video streaming QoE in the context of P.120X. They have some 1201, 2, 3 recommendation series. And PSTR, OQ, MXR quality, objective quality modeling for XR services, and also P.OQAI, objective quality assessment of AI enhanced contentment. So in the last January meeting, they received some contribution to progress these work items. So there is some additional explanation about the work items. So this is so eventually they look for the extended to HDR and 8Ks, and also they look for the collaborating with VQEG, example AVHDs, and also P.NETS phase 3 overcharging long terms up to 5 minutes, and AV integration modules. Initial work streaming include quitting, not currently pursued. And also P.BBQCG, parametric bitstream based quality assessment of cloud gaming services. So there are some working mode, and they received 2 contributions to progress these work items. And PSTR, OQ, MXR, objective quality modeling for XR services. So they are still working on it in the early stage. So it looks like they also look for some collaboration with the VQEG and VQEG IMGs, and they received contribution C34 for these topics. And the next one is the question 19, and this is objective and subjective method for evaluating perceptual audio-visual quality in multimedia and television services. So we have several work items, JDAN NOREP, which we are currently working on. Well, initially these work items, the no reference method covered very wide range of resolutions, but we failed many times previous. So these times we just focus on the full HDs. If we successfully develop recommendations, then I think we can proceed to extend the resolution, for example, to UHD or some 720p, something like that. And then also we have J.source video quality. This is also NR method, but this NR method is just for the head at the head end. So some source, the content source quality is not good. So if the source quality is not good, then it doesn't make any sense to encode them at high bitrate. So if the source quality is moderate, then I think at the head end, they may decide that this quality is average, so we should not use high encoding method for these contents. So this method will help for that kind of decisions. And also but as you can see here, this is no reference method for only source contents. And the J.QUHD is quality measurement method for UHD services. So as you may know, UHD television and the Full HD television, in many cases, the difference is very, very small. So also they, at the head end, they have to determine whether to encode the video contents at the UHD resolution or Full HD resolutions. So this no reference method will help to make that kind of decisions. So these two methods also we can proceed, because in the previous case, after initiating these work items, we did not produce any good result to be developed into recommendations. But as you know, that last few years, the deep learning based method provide much better performance. So upon successful development of J.NoRef, also we can take a look at these two work item tools. And the next one is the P.object recognition estimation techniques of object recognition rate in surveillance video of autonomous driving. This one was initiated by entities, and entity presented 3 contributions to develop this method into recommendations. So they did a very good presentation yesterday. So we hopefully that we can consent this method in September. And also PV or QAM, objective quality assessment method for panoramic videos. This one was proposed, I think, last January. So we also received some contribution related to these work items. So I think they will continue to develop these recommendations. I believe that they can have 2 methods, full reference and no reference. So I think if you're interested, you can contribute to this effort. So I think that's it. That's the work item currently being developed in the ITUT side. And the next meeting happened, the ITUR and ITUT study group 12 meeting happened to be overlaps. So first 2 weeks of September, ITUR study group 6 will have meetings. And the second week, going into 3rd week, ITUT will meet during that time. So at this time, if you visit Geneva, it will be possible to attend both meetings. And also ITU question 14, plan to have interim meeting. I think it's next week in Stockholm. Okay, so this concludes my presentation related to IRG AVQAs. So any questions?
Thank you, Julhi. Anybody has questions about the activities? No, I don't see anything from the group here, Julhi. Anybody online? Okay, so I see Balu raising his hand. Balu.
Actually, thank you so much for the presentation. I was just wondering, like, if there is a way to get like more frequent updates, or like how do we keep ourselves like up to date about like some of these programs?
Well, you need to be a members. There are several possibilities. For ITR side, you can be a member state, which means you are representing your countries, or your company can register as a sector members. Then, for example, YouTube now become sector members, then you can access all the current document, all the contributions, and all the text being developed. So we call them temp document PDs. So if you are a member, you can download all those documents immediately.
Okay, I'll ping you separately on like some of the next steps. Thank you.
Oh, okay, thank you.
If I may just add something that may not be known to the people, at least for US-based companies, you always have access also through the US delegation, right? So you don't necessarily need to be a member, like a corporate member, but if you're part of the US delegation, Balu, you can also have access. That's like, say, an alternative that in the past, at least, companies used. So I can sync up with you offline and give that path in case Google is not, a direct member.
Yeah, that sounds good. Thanks, Jan.
Any other question for Chulhi? Okay. Anything else to report, Chulhi? Or otherwise, we can maybe.
Yes, I
do you
think
have anything else?
Yes, IRJ VQA side, I think I'm done, but I have just like to inform the groups that after the meeting yesterday, the Q19 interim meetings, I sent some email to the proponent to make some decisions raised during the meeting. So I think we can have some consensus on the unsolved topics, so we can solve them as soon as possible. So I will inform the progress as we make the progress.
Thank you, Chulhi. This is very good, and again, looking forward to the update. I think you can keep VQEG, of course, in the loop, but I think to directly contact the people who requested to be added late into the project is the best way to move forward. Thank you for your efforts and your leadership there. Okay, I did not bring it up in the morning, but we have time now, right? It's 9:30. We have until 10:30. But there was one last-minute presentation that we I discussed. Sorry, Sal, I did not put you in the loop. David Ronca has done some interesting work. So I made the last-minute addition into the presentation. So if the group here agrees and everybody online, and he can maybe present. Are you ready to do the presentation now, if necessary? Yes, we can always leave it for tomorrow. No pressure. Police thing. Okay. Yeah. So let's schedule then. Break is at 10:30. 10:30. Yes. So again, we can have an extended break. We can discuss a few other administrative things that we shouldn't discuss and decide, but we can just give brief, preview of some of the things that we will be covering in the administrative session. We can discuss next meeting, Sal, if you think that's appropriate, use of the time, or we can, I don't see Patrick, because Patrick has 3 back-to-back presentations in the afternoon. So he had asked to maybe split them up a little bit so people don't get bored, but I don't see Patrick, so that's not an option. So either we have the first installment of, no problem, David, don't worry. So any preference?
I mean, we could just briefly mention upcoming meetings. I mean, apart from that, we would probably discuss it tomorrow, but maybe it's something to think about. I mean, we have online meetings, usually in the fall, and maybe it could be good to reflect a little bit about the timing. We had it last time. We had it a little bit earlier. I mean, the previous meeting has been mid-September, mid-December. Now we were more in November, and I got some feedback that people thought it was better with mid-December. But so it would be interesting to hear whether we should target December again.
Yeah. So yeah, let's refresh the memory of those who don't remember. We have now more or less converged into a one physical presence like this one and one fully virtual. So the cycle now is to have the fully virtual one. I just want to remind you also, Sel, that especially Patrick insisted on having maybe an event between COMEX and PCS that would place us in the early December, I believe.
Yeah.
So
I thought it was earlier, but maybe I was.
Let's bring up the calendar. Do you mind? Let's do a straw poll. It's not going to be final, right? Tomorrow we can finalize things. But again,
Yeah.
I think having this is just my opinion, right? I did not even have a chance. Well, actually did sync up with Sel a little bit, but I think that COMEX is a very good both venue, has the right people already. It just happens to be also chaired by this year by Pablo, so we are de facto present there, right? So, but I would say it's a good outreach activity, also maybe for Naim to think about where we can have a permanent presence, right? Just like Colinet has a permanent presence, and rightly so, because that was really the root of that COMEX grew out. I think VQEG has a definite place, so we can either have a permanent VQEG session within COMEX. It's too late now. We can have a parallel event, if you like to call it, just like there is the previous day, right? There is a half-day event. We can have a VQEG ad hoc meeting, if you like to call it. And if it happens that COMEX is always in the winter / whatever, October now, right? We can have that being our virtual meeting or hybrid meeting. So there are at least 2 or 3 options. Maybe too late for this time, but I think we can still catch the train on having maybe not hook. It doesn't need to be part of the official program, by the way. So that is, this time you do what? We can check, okay. So again, I think let's put it in the long-term or perhaps vision for.
Just a comment, I mean, usually the COMEX is 3 days, so, and also Colinet plan often a meeting on the day before.
Yeah.
So one option is the day after to just co-located, not in the official COMEX program, but we can distribute information about it. But it's up to us to host and plan the meeting, and we are independent, but then in conjunction with the COMEX.
I think this is a good. Again, we can make it officially our one of the 2 meetings we're holding. Anchor that around COMEX, like the day after. But 1 day is not enough, obviously, right? So
No.
It has to be only like maybe the highlights of the previous or the next meeting. So we have to decide on a format. So I would say, let's all mentally think about it so that tomorrow in the official administrative meeting, we can make a decision. It can be an ad hoc decision, but then it could be a regular cadence for the COMEX. I think it will help the conference, first of all. People are traveling anyways, maybe half of the audience, I don't know how many will travel to COMEX. So the logistics is easy. The theme of the conference is, I can say, de facto the same. So I think it's a waste if we don't use that opportunity.
Sure.
Okay.
And also, I mean, just think about also the next face-to-face meeting, probably most likely located in Europe. Timing, any additional thoughts about how to arrange it and so on. We are discussing with a potential host, but there could be other options as well. So.
Yeah. So again, if there anybody, again, we favor Europe just because we want to have a, we don't want to be always North America based, right? So anyone can propose. We also like Japan, by the way, if that's an option. But again, please probe internally within your institution, hey, is there an opportunity to host? By now, you know the logistics, right? We need a big room, 50 people more or less when it's in person. We need to have some accommodation when it comes to breaks, particularly coffee breaks. It doesn't need to be luxurious, right? It doesn't need to be, it has to be functional. And then, because I think it surfaces from time to time, for a corporate, let's say, host, it's much easier to provide, like you experienced this time and like in the past for other cases, like meals, etc. But I don't think it should be a requirement for academic partners to offer anything like that. So I think we are all very cognizant that the budget when it comes to a university or a research is very limited. So we don't really expect that they cover full cost of all activities. And I think it's very reasonable for anybody who travels, as long as there is no registration fee, which by the way, nowadays for a conference is $1,000 or upwards, which is a little bit crazy, but that's what it is. That I think should still remain a principle, right? You do not pay for registration, right?
I think I would like to be clear. I mean, the basic requirement for hosting a VQEG meeting is a room, and nowadays a kind of a video system, but it could be a PC with a Teams or Zoom. It doesn't need to be more fancy, or maybe a larger screen. Maybe Wi-Fi would be nice. But anyway, it's very, very basic. Everything else should or could be financed by the participant.
Yeah.
Say meals, coffee, anything that would require a cost for the host could be borne by the participant themselves. Anything else is just a bonus. And this is kind of very much bonus this time, I would say.
Yeah.
Thank you so much.
Yeah. So again, please, check internally and just let us know, me and Sel and Margaret, you know what? I could host next spring, right? Look at the time zones and say, oh, March, maybe May, is a good time considering everything else, right? Look into the calendars and please get back us. But let's pause the discussion. I see David made it record time. Yes, Narciso. I charged all of them.
I think that the idea of joining VQEG with QOMEX after the shift in the QOMEX time scale, that means instead of being in June, that now QOMEX will be probably according to the suggestion of the steering committee. If the next QOMEX is a success, we expect that in Madrid, it will be early October or late September. I think it's a good idea. For this year, it's almost full up. The whole week is completed. That means we will have an AOM workshop on Monday morning, a Qualinet meeting on Monday afternoon. Then on Tuesday, Wednesday, and Thursday, there is the main QOMEX conference. And on Friday morning, there will be another workshop at a foundation that works with Nokia and ourselves, that is helping the mentally disabled people and people under socioeconomic vulnerability. But in case we consider that it could be possible, the program is not fully complete, maybe open a part, something that's saying we are planning to do that in the future.
Yeah.
That could be, I don't know, probably Friday evening could be so late, but Friday evening is still free, or in any other hour at the end of the conference. So if we consider that, it will be a good idea to throw the seeds and to allow it to yield for the next year.
Thank you. Yeah, and I think at least the four of us, right? The organizers of QOMEX and
let's start later
we'll
on.
start the thread and determine what would be a good approach.
Yeah, we also need to reach the steering committee for QOMEX stuff. So there's things to be done, but I think in general, it's a good approach. So let's explore it.
Thank you. So, okay, we have time. So you're not under pressure. So take your time. Before David starts, I'd like to take maybe 2-3 minutes to make a personal introduction to David. So many of you, not most of you, know him. First of all, because in 2017, he was at Netflix when I was at Netflix, so we hosted and we had a great time. But for those who don't know, David is really one of the forefathers of, let me use the word video quality to the masses, right? He worked together with me at Intervideo. So Intervideo was a company that was providing a software DVD player. So people, allow me to say, millions of people enjoyed high DVD quality on their PCs because of the work that David did. Later on, he joined Netflix. So many hundreds of millions now people enjoy higher quality because of the work that he and the team did at Netflix. And since 2019, he's been at Meta. So now billions of people. So he's going like an order of magnitude in his career, but his passion for video quality is very well known among the industry. Yes, he hasn't been very tightly involved in this group, but actions speak more than words. So he will speak about a few things about himself. I'll let him introduce maybe some more lesser known facts, but me as a friend for 25 years now, I really like to acknowledge David Ronca, the person, the engineer, the manager, the director, for all the work that he has done to improve video quality for the billions around the world. So, up to you.
Thanks, Giannis. Am I here? Yeah. And now I'm thinking, okay, millions, hundreds of millions, billions. The next order of magnitude is trillions, and I'm trying to figure out how I'm going to get there. I think that'll be a little bit. So yeah, thanks for the introduction. Small correction, at Intervideo, I actually can't take credit for WinDVD. It was a phenomenal product. My work was on the broadcast side, which actually where cable and broadcast TV got into MPEG-2 transport streams, the systems layer, and did a lot of work there with time shifting, recording, buffering, and playback. And that really built a good foundation for Netflix. Really, you know, I always say my world started at the output of the encoders, the bit streams, parsers, muxers, DRM, and then kind of building up from there. Then it got into the encoders when Giannis and I started working together. Actually, 2010, we wrote the first patent at Netflix on complexity-based encoding, which was the foundation for all of Netflix at-scale systems, but also led Giannis to this wonderful place called Convex Hull encoding. And Convex Hull has shaped so much of the way we think about video here in terms of both, you know, cost, power, benefit, everything. So
I'm going to interrupt you there because, yes, I forgot about this. The very first, let me say, semi-public disclosure of the dynamic optimizer concept was at the VQEG meeting in 2017. It was just fresh out of the oven, and you know, it was presented in this group. And then I still remember that David, when he addressed the group, he made the statement that complexity is the currency you use to trade off with quality, and that later became another thing. So yes, thank you for reminding me.
And by the way, so that was strictly sampling the resolutions at multiple CRFs to kind of choose the optimal convex hull. But then after that, Yanni developed this new model of encoder efficiency per watt. So now we actually predict our system usage because we process over 1 billion videos, about 6 billion minutes of video a day. And in order to map out our systems, we have to make cost benefit trade-offs. And that curve where the x-axis is watts and the y-axis is efficiency is fundamental to what we do. And it's also, you may have seen a lot of papers coming out that have come out of Meta joint with Intel, Meta, others. Anyway, so I'm going to move on. I'm going to talk about, so this is a Mile High video, but you guys in Mile High video, we only had some screenshots. Now I have a real demo. So I'm going to give you the background, assuming most people here weren't there. And I'm going to talk a little bit about VCAD. It's a quick presentation and then some demo. So let's start out with where our motivation is. So Meta is all in on AV1. For us, we see AV1 for the next 5+ years as our dominant codec. Why? For us, codecs are not a, we don't deploy codecs to make statements. We don't deploy codecs to get points to say we did. We deploy new codecs to bring value to our users. And we were late to the AV1 game. Other companies, Google, Netflix, others announced AV1 streaming a long time ago. But for us, it was like, how can AV1 actually deliver value? And so once we answered that question, was then we were able to start pushing AV1. Once we're seeing significant wins for our users, then the company leadership gets behind us and motivates us to move forward. So the way we're getting value is improved user experience and a reduction in mobile network congestion. And I think both of those are obvious. AV1 generally is about 30% better for our benchmarking, 30% better than HEVC and open source VP9. It's 15 to 20% better than the closed source VP9 encoder we use. So what does all in mean? Well, we actually, I'll just jump to it. We're actually above 60% of global watch on Instagram is AV1 today, and more than 50% of global video watch on Facebook is AV1 today. And that means that almost 60% of all video bits being delivered to end users today are AV1. In order for us to reach this, and by the way, we have a goal, we like to be up to 90% in 2028. And because of the lack of hardware encoders, the slow progress, this assumes that 80%-ish of our AV1 delivery is going to be software decoded. So how are we going to achieve this? The way we have worked and moved forward and actually surpassed other companies is that we spent a tremendous amount of time understanding and exploiting the AV1 ecosystem and the Android ecosystem, I would say as well. So we brought new tools into SVT AV1. We've actually developed decoder-friendly recipes. You make minor trade-offs in codec efficiency with significant reduction in decoder complexity. We've gotten about 25% reduction at a cost of less than 5% efficiency. And since we run at a speed 6, we simply bought that efficiency back by moving to speed 5. So with a little bit more compute, we had a zero loss. We actually had a net gain in efficiency, which additionally contributed to wins. Having ecosystem aware AV1 is essential, right? We can't just throw AV1 streams out on devices, software decode, and hope that we're going to be successful. We can't give bad experiences to users on low power devices, etc. And then we have this new tool called VCAT, which I want to talk about today. So let's talk first about the ecosystem. It hasn't been pretty. HEVC was finalized, the spec was final in 2013. By 2015, mobile devices were shipping HEVC at the high tiers. By 2020, nearly 100% of all shipping devices have hardware HEVC. Everybody kind of assumed that AV1 would follow the same track, and the VVC people are also thinking VVC will follow the same track. But we see AV1 launched in 2018, and here we are 7 years later, and at best 10% of shipping devices today have hardware AV1, and that's not going to change significantly. We believe in 2 years, mid-tier devices are going to start getting hit AV1, so it could be 15 years or at least 12 years from the finalization AV1 spec before AV1 hardware is broadly deployed in the mobile ecosystem, and particularly in the Android mobile ecosystem, which is, you know, outside the US and UK is like the dominant, Android is dominant. So we're going to have to do software, and if we think about it in tiering, right? We think about devices in high, mid, and low tier devices, and high tier, whether they have hardware or not, is irrelevant because they have plenty of they have very high quality batteries, they have very modern CPUs, so they can easily handle software. You get to the low tiers where it really gets challenging. This is not just a problem for AV1. VVC, if I've listened to a lot of talks and read about plans for VVC, and VVC deployment in the near term is also going to be critically dependent on software decoding. The first hardware mobile VVC, I think, might show up in 2026 or 2027. That will be probably 1 or 2% of shipping devices. By 2030, you'd be lucky if 10% of shipping devices have VVC. So it's not just a problem for AV1. So there's this problem, I think, and that we have to reckon with, that modern codecs, the world of codecs has changed, right? And the existing codecs, even AVC, which is still the dominant codec today, is a really good codec, provides good fundamental value, right? And HEVC adoption has not been where everybody hoped it would. VP9 has filled some of that gap, but things are moving slower. And the nature of the economics of the mobile ecosystem are putting limits on the ability for rapid refresh. So that's actually the fundamental reason why hardware decoders are slow. When you have a $60, $70 device, there is not a lot of margin there to put a very large, expensive decoder on the SoC, right? That's a very expensive operation. So if you have a $1,000 device, it's easy. Anyway, so what we're finding is that we believe software decoding is inevitable, right? And a few years ago, this just would have been like a really difficult thing to say but modern CPUs are actually getting very, very powerful, very cost efficient, to the point in the data centers, we're actually about to see CPU software efficiency and hardware efficiency cross to be roughly equal, right? And that's for a given quality, encoder quality. Hardware can only take quality so far, software can go much farther, but software is pushing into hardware space such that the opportunity of hardware encoders is being diminished in the use cases where hardware is not needed. There are use cases where you must have hardware. So software decoding is inevitable. There's broad confusion around ecosystem support for software AV1. Nobody really knows, and you hear a lot of different information. VVC is going to be even more difficult, right? Because VVC is more complex. We believe it's 1.5 to 2x more complex than AV1. We'll soon be able to test that. So as we were working on AV1, this is actually the device that really changed the way we thought about software AV1. So this is the Moto E13. It's a $90 phone on Amazon. It has 720 display, and it has a Unisoc SoC. And Unisoc actually did something unusual. They bundled an highly tuned software decoder with this device. And when you look at it, if you look at it naively, you think you have a hardware decoder on a $90 phone. In fact, you don't. It's software running at the SoC layer underneath the OS. So the OS thinks it's hardware. This device, and that decoder handles up to level 3.1, which is appropriate for this device. And it's a very impressive performance. We're seeing, it's 16 hours of continuous playback. We're seeing battery drained. Only 51% of the battery was drained. So 49% was still there after 16 hours of continuous playback. From that, we started running benchmarks. These are our benchmarking conditions. All right, we're looking for 16-hour battery drain. Actually, it turned out being 17. Radio's off, display brightness 25%. We're using local files, continuous playback, and 1080 or 720/30 appropriate for the device. The E13 does not need 1080 because we would simply downsample it. So this is a 1080 benchmark results. And I have the iPhone 15, which is considered at the time one of the more powerful. And you can see the battery drain playing 1080p 30 at 17 hours at 35%. We use dominantly VP9 software. So VP9 software is our reference. This is a blue line at 54% of battery after 17 hours. This is interesting. On the same Oppo device, after 17 hours of AV1 software using our optimized decoder-friendly recipe, we're at 42% of CPU or battery. I'm sorry, 42% of battery. So we stopped the test at 17 hours because I had to go to bed, but easily we could have run that 24 hours, possibly even to 30 hours. This is the 720 class devices. And you can see the Moto E13 is the yellow line here, landing at about 49% after 17 hours of testing. So we also have some devices, you can see some very uneven. Here we have a device, the battery is dead after just barely 13 hours. We have the G-Powers a little better, and I'll talk about why. And then of course we have our high performance CPH 2625 that's just doing really well. So what have we learned in all of our benchmarking? So AV1 software must have an ARM v8. It must have 64-bit Android OS installed. It must have more than 4 cores. It must have a process technology of 12 nanometers or better. And it must have LPDDR4 or better. We prefer A55 cores, A53 cores, if you know about ARM architecture, the older cores. they're troublesome, and some devices do well and some devices do extremely poorly. And it's hard to know on the A53s what kind of performance you're going to get unless you test it. The A55s, those are newer, those all are 12 nanometer or better, and they're performing very well for us. So it's pretty safe to say you can deploy software decoding on any Android device with an A55. There's only one SoC we know of that's has a 28 nanometer process. That's an old one, so you can filter that out by SoC. That's a Unisoc or Spreadtrum. All the rest are there. So you could do at least 720p on these devices. And with the devices, if you let the screen be your limiter, if a device has a 720p screen, you can assume it's a lower end A55. You can level limit 3.1. You could do 4.0 if it has a 1080. So we think leveling is really important. And for those of you familiar with hardware codec leveling, that's the way hardware decoding works, right? Decoders advertises support for a level, which is usually thought of in terms of resolution, but in fact, it's really about pixels. So level 4.0 is typically thought of as 1080p 30. Level 3.1 is typically thought of as 720p 30, et cetera. 720p 60 would be level 4.0 and 1080p 60 would be level 4.1. So as we look at our devices now, we're starting to think of them for software decoding in terms of level limiting them. The Moto E13 would be level limited to 3.1, for example. If you look at our ecosystem, what does this mean? This is what we have. You can see by ARM version, and you can see that most of our devices have ARM v8, either A53 cores or A55s. We got a small cohort of ARM 9, and then we've got some unknowns, and then the yellow strip is 7s. You look at the node size for A55 and cores, and we have this small cohort of Spreadtrums with 28. Everything else is 12 or better. So basically, nearly 100% of the A55 class Android devices can handle AV1 software. It's at level 3.1 or better. You look at the A53, we've got, these are the large, the orange, green, and light blue. Those would have to be excluded. The others would not. And so we end up with a ceiling, and this is from a hardware perspective, the ceiling is about 85% of the Android population in the Facebook ecosystem could support AV1, but what's not the actual opportunity is the intersection of these plus those that have 64, which all the modern, like the A55, as far as we've seen 100% or A64, the A53s are where you usually get into a lot of 32-bit OS. So the problem we have is you can't probe to know the node size. You can't probe to know the memory version. You can know the core types, right? You can know the OS version. You can know if it's 3264 or the ARM version. But I'm going to jump ahead a little. A simple memory bandwidth test helps us segregate these or split these devices into buckets. I would put this low bucket. This is in 1 second, how much memory, how much data could I move through memory? This low bucket here, generally, I would say no AV1, though we have one device here that's kind of okay. These would say we can do AV1. These two are okay. There's a slight anomalies, and these are easily AV1 here. So we're working on a memory bandwidth approach to classifying devices. Finally, VCAT stands for Video Codec Acid Test. For anybody familiar with that term, it's a universal engineering term. Anything you're testing, whether it's a structure, whether it's concrete, whether it's a motor in a car, or software or hardware, the acid test, you're pushing it to the edge. Military, like they're going to put it in and bake, they're going to run it under heavy load at 160 degrees Fahrenheit, right? They're going to run it at minus 200 Fahrenheit, right? Or things like that. They're going to put things down at 5,000 feet in the ocean to make sure they can withstand the pressure. That's an acid test, pushing this to the limits of its capabilities. So hence VCAT. It's primarily focused around battery drain, and it's right now exclusively Android. The goal is to be able to run 24 plus hour tests, and also to be able to have many devices. We have a partner with hundreds of Android devices. We'd like to be able to run simultaneous benchmarking across a large population of devices to make it cost efficient. We plan on supporting all hardware and software decoders, and also includes VLC bundled. So why do we need this? I'll go right straight to it. We all know 3GPP, right? Has anybody seen the 3GPP test conditions for video decoders, for video codecs? 1080p, 4K, QP22 to QP37. An HEVC 4K QP22 is about a 60 megabit per second stream. And I tell our partners, SoC partners and handset vendors, if we delivered video to the 3GPP test conditions, we will burn your freaking networks to the ground, right? You can't do that 3.5 billion. And the problem is, I believe the fundamental problem is the industry is not thinking about codecs from the practical sense. Who would test brakes, right? Well, at 200 miles an hour, I can stop, in 75% less distance than these brakes, right? Well, who cares at 200, right? What do you do at 40, right? So we don't do this testing, and I believe it's a problem. And as the codecs get more complex, understanding how they're actually going to work in the real world should be fundamental to selecting codecs that are actually going to be mandated as part of a device. We don't do that. VCAT is going to hopefully help alter that conversation by getting, making it easy for people to test and understand how these decoders perform on devices in the real world. Okay, here we go, the fun part. The demo, which is totally, we'll see. I believe we'll be okay. So I have a connected Android device. You can see VCAT running. I'll expand it here for you. We have a configuration page where we can set the screen brightness. We pick the threads. How do we want to run this? Typically, we want to start it running at full battery. We want to run a battery drain test. So I have it set to stop at 15%. And then we have the decoders. We can actually come down here and pick whatever decoder we want to use. When we're ready, we simply launch a test. So I'm going to go ahead and launch this test. I will reduce this because in the background, what you have is the server side of this, or the control side. This is, hello? Oh, so this is the telemetry monitoring, which is still a work in progress. But you can see here, we have the details of the test. By the way, I have the device if you want to know what's going on in the device. We have a terminal here where we're sending all the ADB commands. So if you want to see the history of what's been done. And then we have, right now we're monitoring CPU usage, frequency, memory usage, frame drops, and battery level. I'm plugged into USB, so the battery's never going to move. But if you're using Wi-Fi, ADB, you could get battery. There's more. We're going to be putting thermal and a few other graphs on this, but at this point, it's now very easy. I can also do things like, if this works, which it doesn't. Okay, that's because I'm behind a version. Okay, we won't worry about that. Oh, it does. So I actually have control buttons here on the server side where I can control the behavior. So in theory, oh, there you go. See, I pause it. We see the stats, right? I can resume playback. And then I can even stop the test completely. So now we're done. We go back. We got like one more slide, two more, I think one more slide. So the summary, for Meta, AV1 is bringing real value to our users. And it's also bringing value to the network operators because it's part of our strategy to reduce the congestion, mobile network congestion. And because it's bringing value to our users, it's bringing value to us, right? If we're reducing rebuffers, if we have faster play starts, if we're able to deliver higher quality because of lower bit rates, these all result in higher engagement. Higher engagement is a net positive for us as well. So it's a win-win. For the Android ecosystem, hardware is coming slowly. And AV1 software, as I said, is inevitable because of the slow refresh cycle. We do believe A55s, and I believe VCAT and benchmarking is going to help accelerate this. There's still A53 devices being sold today at the same price point as that Moto E13, and yet they have much, much worse video codec performance. So we believe that the benchmarking is going to help push the ecosystem towards newer devices, right, and to more modern SoCs. We're leaning hard into AV1, 90%. The goal is 90% in 2028. And VCAT establishes a model for benchmarking video decoders. It's We'd like it to be used widely. It's going to be available in open source. VCAT itself is built on VLC and VLC benchmark. These are GPL licensed. And so when we release it, we will be releasing our code back into the ecosystem. The website of it, I've written, and when I release that, I will release that as likely Apache. So this is all going to be available for everybody to use freely, bring into your labs, bring into universities, and help, you can, move it forward, do whatever you want to do with it. So with that, I'll leave us up here. Anybody who wants to get in touch with me, and are there any questions?
Thank you, David. Opening up for questions, either in the room or online. First of all, again, many thanks, but I think the group can clearly see the line of sight here between, I hope, this work and what we're doing. I think there are multiple opportunities.
Yeah.
Margaret?
Oh, I'm sorry. I did not intentionally unmute my microphone. Very interesting talk. Thank you.
Thanks, Margaret.
Thank you, Margaret.
So yeah, as I was about to say, I think we can look in this work in two different aspects, right? The first one, the concept of not just pixel quality, but overall QoE absolutely involves the factors that are behind the consumption on a mobile device, how quickly the battery drops. How does that affect the perception of QoE? Because if you give me a choice, it's an interesting research problem. Would I like to see a 4 on an ACR scale for 24 hours or a 5 for 3 hours? Interesting research problem, right? How does the expectation changes based on the impact you have, say, on your phone, then, how. So there are these other factors that compound. That's, to me, one problem. Second one, the framework can be used to conduct, hopefully, crowdsourcing by you probing the device and getting all these signals while the testing is happening. Because right now we all have the usual problem, right? You crowdsource, you don't know what happens behind the scenes. With a framework, with a remote server, that you have the telemetry signals, how many frames were dropped, really when the user was watching, right? What device is it? Is it even eligible to play back, say, an AV1 type of PVSs? A second thought, right? So I would say, and the third one, which ties up directly to the 5G KPI, right? It brings up this very important component. Is visual quality in its purest form enough, or this necessary bridge to how many bits you're gonna send? That's why you need AV1. That's why you need an entire ecosystem to make it happen, and how the 5G KPI is addressing the same problem, right? How do you bring the content providers and the networks under the same roof? I think these are the three, at least to me, key takeaways that relate to this community. And having said all that, any questions again? Enrico.
By the way, I have one comment. Ultimately, I hope this will be called VCAT D, and I'd like to have a VCAT N, and everybody could guess what the N stands for, encoding, right? So that we would be able to also benchmark mobile encoders, both hardware and software. And that would be less about how long can I encode. It would be more about what quality do I get with what presets and come up with.
Okay. Okay, thank you for the interesting presentation. Actually, I know there are many different software implementations of AV1, right? I'm not sure about the coding, but did you test them, or
No, and that's a very, very good question. So from encoding, we use SVT AV1, period. Why? Because we're investing significantly in the decode friendly work, and that is in SVT AV1, although anybody is free because of licensing of SVT AV1 to take that work and copy it into their encoders. So we're only using SVT AV1 encoding, and we're only using David decoding. And the reason, of course, is that even Google admitted that nobody has been able to produce as compute efficient decoding, software decoding as David. And that's why it's the main. Yes, that's now they had their, Google had GAV1, then you had David. They've simply deprecated GAV1, and now David is their software decoder. And there's several reasons for that. One, all of the investment of Meta was actually a significant investor along with Netflix, and I think it's mainly the two of us in the David effort. Actually, AOM initially funded it some years ago, but then ARM has gotten in. And ARM has taken David to a whole nother level. Now the ARM team is contributing in kind through SIMD optimizations and restructuring things like going to I guess if you go to 6-tap filters versus the default 8s, right? They've got new intrinsics that are like much more efficient. So now ARM is actually moving both SVT AV1 and David forward. So for us, I mean, anybody else could use VCAT. They could take it and plug in whatever decoders they want. The encodes already exist, so they could encode with whatever encoder they want to encode with. But we're focusing on the open source ecosystem.
Okay, thank you.
With the
Very
exception of hardware decoders.
Yep, thank you.
It's a bit of an off-the-wall question. I hope you don't mind that. Clearly, one of the big drivers for codec technology advancing is because it's limitations on cellular and bandwidth constraints and so forth, right? And we're somewhat alleviating that, but we're sort of like, so I come from cellular, right, from Ericsson. And so, our limitations are limitations on spectral efficiency and total amount of spectrum we have. Of course, that funds kind of the codec industry, but when we start to resolve these things, either by increasing amounts of spectrum or our efficiencies or codecs themselves, is there some other driver for codecs to keep advancing beyond that?
Well, and this is one of my frustrations. If you plot, starting with MPEG-2 all the way to VVC, and VP9 and AV1 fit in there, but we live them out. You plot the computational costs, right?
Yeah.
It's gone asymptotic.
Right.
It's literally pointing straight up.
Right.
Right. Every generation is at least an order of magnitude.
Yeah.
If you plot the efficiency, it's exponential decay.
Mm.
So I'm spending infinite money to get rapidly diminishing returns, right? So I would argue that the way we think about codecs today is it wasn't broken behind us, but we can't look forward and say, like, VVC is a difficult proposition. Running the benchmarks on their reference encoder, you better have some time. And what about you better have a month or two?
Yeah.
And the next generation, you better have like 2 years, right? Who's going to sit around and run benchmarks for 2 years? So, and Giannis has said this before, and I 100% agree, and maybe VCAT can help. What if the next generation codec delivers VVC efficiency at half the computational encode cost and half the computational decode cost?
Right.
We never think about codecs in terms of complexity, only about bits.
Yeah.
And we only test them at bit rates, again, I don't care what a codec can do at 4K QP22, because that exists that's some other world. I have no idea where that would be meaningful. I don't even think broadcast would use such a configuration, but, and I don't care if you can save 50% bits at that use case. Now, the codecs do provide value in the practical range, but often you'll see the real value. Like we're seeing VVC 10 to 15% better than AV1 in the practical case. That's VVENC compared to SVT AV1, which is not what if you look at their reference, they say, oh, it's 20, 25% better. But yeah, but that's a world where nobody really lives, right? Again, getting back to the car brakes, let's be thankful that car brake technology is not qualified and tested the way video codecs are tested.
Very good. Thank you. That's just the sort of insight I was looking for. Usually when things get asymptotic and in one area in computing, you start to push on the other directions.
Yes,
you know what I mean?
Exactly.
But that just kind of tells you how hard it's been to push into cellular, and that they're willing to have, 25,000, different probing modes or something like that.
What's amazing to me is mobile network companies that are heavily invested in the current model of codec will not be interested in talking about the 3GPP test conditions. Even though we tell them if we deliver to these conditions, we will burn your network to the ground.
Yeah.
It's a curious world.
It's probably just kind of finding the right kind of connections and overlaps and stuff like that. But you make an obvious point that nobody's going to try to push 60 megs, video anymore.
I mean, yeah, we're talking 720p. We're talking about 1 to 1.5 megabits.
Yeah.
And that's even high.
Yeah.
1080p, we're talking about 1.5 to 2 or 3, right? We don't live in the 20 megabit per second world anymore.
Right. Yeah.
Cool. Any more? I'm happy everything went well. I love off the wall questions too. So.
Anything additional? Otherwise, we give everybody like an additional 10 minutes. Who doesn't like a longer break, right? Shall we do that? All right. Thanks again, David, and we adjourn.